A few years ago, a friend and colleague of mine came to me with a mathematical problem. He had been trying to solve it for some time using trigonometry. He had brought it to me because he had been a student of mine in my differential equations class. And even though this wasn't a differential equations type of problem, he had seen me deal with trigonometry in that class and thought I was pretty good at it. Ultimately, I didn't use trigonometry to solve this problem, but I like it as an example of how you can simplify a problem just by looking at it in the right way. So let's take a look at what the problem was. The idea is that you have a house, and again, the type I've drawn, which might also be drawn by a fifth grade child with a ruler. And you want to put a porch on this house and a cover on the porch. And you want the porch cover to come out by a length of L. And you want the attaching part of the roof of that porch to have a certain slope to it. Okay, and so those are the two parameters: the length of the overlap and the slope of this. And what you want to find out at the end is how long this will have to be. Okay, and so Vern, my friend, had understandably attacked this with trigonometry and found it to be quite difficult. One thing that we sometimes forget when we are attacking a problem is the value of a coordinate system, and that we have the power to choose that coordinate system. So what I'm going to do here, I'm going to bring in some of our lines, but I'm just going to use the ones that we need. First off, I'm going to have the top of the porch. So this will be the roof, I guess I should say, of the porch, the ceiling of the porch. Okay, and we're going to have it be of the overlap here to be of length L. Okay, and here I'm going to have the original roof of the house, and I am going to draw it in as so right there, and I'm going to say that it has a slope of m. And the slope is a particularly useful thing because this is the way carpenters working on roofs think about them. They'll think about the slope of the roof, how far it runs and how far it rises, and so that is captured within a slope. And let's see. So actually, I'm going to change this because I worked this out differently. I'm going to call the slope of the original slope of the roof, I'm going to call it n. Yeah. Now, we're going to have the piece of roof that we tie on to cover the porch right here, and I'm going to say that it has a slope of m. Okay, and we're going to say the overhang here again is L. And so now I've just drawn geometric objects, but it's time for me to kind of think about what I'm going to do. I want to know the length of this thing, and for that it's best if I put in my origin here, and so let this be my y-axis, set the ceiling of the porch to be my x-axis, and I'm going to have the point where this the line of the new roof intersects the line of the old roof. I'm going to have it at a point x prime, y prime. Okay, and so what can my idea is that if I can figure out the coordinates of this point, then the distance from here to here is the length of this board. Okay, the solution to that problem. All right, so having set this up, let's do some thinking. The original roof, okay, it is y is equal to n times x minus n times L. And you can check this. This is the point L0. If I put in L for x here, n times L minus n times L is 0. So this is the line going through there. My porch roof is easy. It's just y is m times x, because it goes through the origin and goes straight up like that. Okay, so this is the setup. I now need to just find out where this line and this line intersects to find the coordinates of that point. Well, let's see here. At this point of intersection, my y star is equal to n times x star, and also my y star is equal to n times x star minus n times L. And so my n times, m times x, so my m times x star is equal to n x star minus n L. I can do a little messing around with this. This will give me n L is equal to n x star minus m x star, and which is n minus m over times x star. And so in solving, I get my x star is equal to n L over n minus m, n minus m. There you go. I can now substitute this value up here and then get my y star is equal to m n L over n minus m. Okay. So that is the coordinates of the point of intersection. Okay. To calculate the distance, I apply the Pythagorean theorem and get that my distance squared is equal to n squared L squared over n minus m squared plus m squared n squared L squared over n minus m squared. I have common factors here that I can bring out. I get n squared times L squared over n minus m quantity squared times 1 plus m squared. And solving this, I can say d is equal to n L over n minus m times the square root of 1 plus m squared. Okay, and notice my slope of m is greater than my slope of n, so I actually need to put in an absolute value here, or I could, you know, if I want to, I could just flip that order around to get rid of that. Okay. And so here I get something, it's algebra. The difficulty isn't in the working out of the algebra. The difficulty is just in putting the right coordinate system on it to begin with.